Mining has a long history of employing large machines. Some of the largest machines ever built were designed for surface mining. Some of them are still in production. Others have perished with time, and hardly any of their remnants are left behind. But there is a gigantic beast that is now in sleep, yet standing as tall as it used to be during its glorious working days, the Big Brutus. In West Mineral, Kansas, United States, there is a mining museum that is the home of this giant rope shovel. Every year, around 22,000 to 30,000 people visit the Kansas plains to see this 16-story tall engineering marvel. And it is, so far, the world's largest electric rope shovel in existence. Currently, the largest rope shovel available on the market is the P&H 4800XPC. It stands 73 feet tall and has a 50-foot long and 49-foot wide upper house. With its 92 cubic yard dipper and payload capacity of 135 short tons, this largest operating shovel of the current time can fill the world's largest dump truck in just a few passes. On the other hand, the Big Brutus is much heavier than the P&H 4800XPC, with a total weight difference of 3,847 short tons. It stands taller with its 160-foot-high boom. Its machinery house is 79.5 feet long and 58 feet wide. But interestingly, this behemoth has a 90 cubic yard dipper with a payload capacity of 150 short tons. It is so large that you can park a D9 dozer in it. Despite being larger in every dimension, the Big Brutus could carry just 15 short tons more than the uncrowned largest operating shovel of the current time. This highlights the changes brought about by technology, as well as the various demands of today and possible concerns in the future. But what led to manufacturing such a large machine in the past? And why don't equipment manufacturers produce larger shovels when the technology is way better than before? Presently, mine owners prefer cost-effective solutions over large mining machines. Climate change and automation technologies are also changing the mining sector significantly. In the last 150 years, the mining sector has seen many changes. In 1964, mining was very different from today's mining practices. Mining companies wanted more production, and equipment manufacturers were in a race to design and assemble larger machines. It led to the manufacturing of many giant machines for mining that were the largest of their kind and the largest in the world. The very first generation of rope shovels was run by steam engines. At that time, coal was the primary source of harnessing energy. In the late 19th century, the electricity network expanded over many states. Access to electricity for commercial and domestic users significantly increased the demand for coal. As a result, a new race started between companies to build more and bigger units of mining equipment. In the United States, the annual coal production was only around 50 million short tons in 1875. It went above 678 million short tons in 1918. Meanwhile, Bucyrus, a pioneer mining equipment manufacturer based in Ohio, became famous for its steam-powered rope shovels. Those first-generation shovels weren't just confined to mining, but they were also used for mega construction projects. The 51-mile-long Panama Canal, through which cargo worth $270 billion moves every year, was dug out by the Bucyrus steam engine rope shovels. Steam engine power shovels featured a fixed mast and swinging boom, similar to a quarry derrick. A bucket was linked to the end of a dipper stick positioned on the boom. The boom was lowered to allow the bucket to dig an arc through the cut face, then lifted and swung to dump. Manual swinging and dumping involved a man on one side of the shovel hauling a rope to swing the boom back and forth, while the guy on another side used to tip the bucket. The shovel was powered by a vertical boiler to drive a double-drum chain hoist. These shovels were moved on railroad wheels. Bucyrus helped pioneer the use of electricity as a power source as far back as 1917, though conventional electric motors weren't suitable for shovels. In 1919, Bucyrus invented a new DC electrical power system, which is known as the Ward-Leonard Motor Speed Control System. This motor speed control system became standard on all electric shovels. The Big Brutus had the same technology. In fact, its original name given by the company was Bucyrus Erie Model 1850B. Two 3500 HP electric AC motors mounted in the center of Big Brutus were connected with their respective DC generators via a shaft. These motors run at a constant speed and transform AC electric power coming from the grid into mechanical power for the DC generator. The combined AC motor and DC generator is known as the genset. By feeding the produced electric power through a network of variable resistance devices, the Big Brutus was able to control the speed of its main motor. Overall, the Big Brutus had 13 gensets that were used to power 8 hoist motors, 3 swing motors, and 2 crowd motors. From digging out to discharging the mining material, the Big Brutus was capable of completing a digging cycle in 1 minute. But to perform just one digging cycle, it used to take 7,200 volts. According to some estimates, this rope shovel had been using more energy in a day than could run a city of 15,000 people. Empire District Electric Company was responsible for supplying 3-phase electricity to this gigantic shovel. From the supplier to the P&M substation, the electricity was transmitted by overhead lines. Then, the P&M company had a network of utility poles and a 4-inch diameter ground cable. From the substation to the shovel, it was a 2-mile power transmission line. A cable handling machine is deployed behind the rope shovel. It has a cable reel to feed or retrieve cables when the rope shovel moves. Other than the cable handler operator, a team of 3 men was required to control and operate the Big Brutus. They included a shovel operator, a groundman, and an oiler. The shovel operator sits in the cab of the Big Brutus to control every dipper digging and shovel swinging of the machine. The groundsman on the ground had the duty of guiding the shovel operator when the shovel had to move backward or forward. Lastly, the job of the oiler was to maintain the oil in all the hydraulic systems and make sure they kept working properly. Operating such a giant was difficult, but building it was even more. It took almost a year to build this monstrous machine. First of all, they build a cribbage by cutting large timbers and laying them down like a building structure. Then, they lifted and placed lower deck components on the cribbage using a heavy-duty crane. This was done to integrate the lower deck components with the undercarriage later. For instance, they welded 4 hydraulic cylinders under the lower deck. They will work as the legs of the shovel and leveling devices. Later, these hydraulic legs were connected to the undercarriage truck. The Big Brutus consists of 4 undercarriage trucks. Each truck works as a separate unit of wide tracks, and each rectangular pad of the track weighs around 2,000 pounds. Every truck could be moved separately because each had 2 dedicated 300 horsepower motors. After assembling all trucks of the shovels, they were crawled under the lower deck, using electric power to weld each with one of the installed hydraulic cylinders. In this way, the undercarriage gets connected to the upper body of the shovel and becomes capable of standing on its own feet and maneuvering itself. But this monster could travel at a speed of 0.2 miles per hour. Moreover, the undercarriage is so big that a man standing between the upper and lower tracks cannot be taller than that. The track system can only move the shovel back and forth. To revolve on its own axis, the Big Brutus needed a swing rack. Like a giant cog, a swing rack enables the machine to rotate the upper house horizontally along with the boom and dipper. For installing the swing rack of Big Brutus, it took a team of welders who have been working day and night to build this giant cog in 3 shifts. One after the other, each heavyweight component was lifted, placed and assembled to complete the Big Brutus. This includes the upper section of the shovel, which houses critical components known as the housing. After installing the main machinery, such as motors, hydraulic pumps, electric systems, etc., they had to cover all sides of the housing section with side house panels. It had been 6 months since the assembly process began, and the workforce was now dealing with winter snow. During this time, another team was working on the assembly of the boom. They had to attach the assembled boom to the A-frame of the shovel. For this purpose, they erected the boom with a crane and used high tensile wire ropes. Now, the dipper stick needed to be integrated with the saddle block. A dipper stick allows the rope shovel to push the dipper forward while cutting and take it back while loading. The forward movement of the dipper stick is called crowding, whereas the backward movement is called retrieving. Instead of using the crane, they hoisted the dipper stick using the boom of the rope shovel. Then they connected it with the dipper stick. On the day of its birth, Big Brutus was welcomed by many miners who came with their families to witness this enormous beast in action. The site where Big Brutus was deployed had seams of bituminous coal at varying depths, ranging from 20 to 69 feet deep. The Big Brutus was needed to remove the upper layer. This upper layer is known as the overburden, and the process of removing the overburden to obtain the valuable ore is called strip mining. Before initiating the digging process with the Big Brutus, explosive holes were horizontally bored into the strip pit wall. This rotary drill was able to make a 5-inch diameter and many-foot-long hole. Subsequently, the explosive expert fills with explosives and then detonates in a controlled manner to soften the hard rock for the Big Brutus. Then, this coal monster starts removing the overburden. With each bite, Big Brutus was able to scoop up 90 cubic yards or 135 tons of earth. Furthermore, in just 60 seconds, Big Brutus could extract the overburden below ground level and pile it up to 150 feet high. Once the overburden was removed from the stratum, a dozer with a ripper was used to pull out the coal layer. Next, the coal was excavated with a smaller shovel and loaded onto dart trucks. This coal was obtained for local electrical power generation. Those dart trucks take the coal to a facility where it is refined for power generation. The refined coal was then transferred to the power plant via train lines. Big Brutus operated for 11 years, from 1963 to 1974, removing overburden from approximately 9 million tons of coal. However, this $6.5 million powerhouse was built to serve for more than 25 years. At the time, Pittsburgh and Midway Coal Company had several challenges in operating its mining activities. These challenges included rising competition from other mining sites in Kansas that caused a reduction in the price of coal. An energy crisis led to an increase in the cost of electricity. The last monthly electric bill for Big Brutus was $27,000. Moreover, strip mining raised climate concerns among the people. They started to oppose the extraction of coal. The change in mining trends not only shut down the mining site, but also retired the Big Brutus too early. Pittsburgh and Midway Coal Company tried to sell Big Brutus, but it was too large to be moved anywhere and too costly to continue its job. In 1983, the Pittsburgh and Midway Coal Mining Company donated the machine to Big Brutus Incorporated, a non-profit organization of local individuals interested in the preservation of this rope shovel. This monument is still there, telling a magnificent history of the past and the people and machines that worked along.
The modern machines you see around today are the result of ages of progress made in the fields of science and engineering, to which the best minds of their time devoted their lives. Take a look at the D11. This sophisticated dozer is a true piece of engineering wonder, proudly exhibiting features from its ancestors, plus the cutting-edge technology of today. From the back ripper to the front bucket, the D11 is 34 feet 6 inches long, 11 feet 10 inches wide, and 15 feet 6 inches high, weighing more than twice an M1 Abrams tank. It's the third largest and most efficient dozer in the world. It was the era of a whole new revolution. Mankind had learned to use steam power and fuel combustion. Farmers were using tractors to plow land, but California's soggy peat soil made it nothing short of difficult. One man named Benjamin Holt decided to do something different, becoming the co-founder of today's Caterpillar. At that time, the railroad system was at its peak. Industries like mining, construction, and transportation relied on railway networks. Holt knew his company wouldn't grow if their tractor remained under the mercy of soil conditions. He first experimented with wider wheels, even trying 18-foot wide wheels. But that made him realize how the size of machines affects their efficiency, cost, and usability. He then spent years developing a whole new alternative to wheels, which could enable his massive tractors to navigate across all terrain types. In 1914, on Thanksgiving Day, Holt instructed his mechanics to remove the rear wheels from the 40-horsepower Holt Jr. steam traction engine and replace them with a pair of tracks he had designed. His devised tracks were 9 feet long and 24 inches wide. Each track shoe consisted of 3x4-inch wooden slats bolted to an endless chain. It shifted the weight of the machine on rollers anchored to a supplementary frame. This new patent by Holt was a commercial success, opening new avenues for the tractor's usability.
West Aurora Street in Stockton, California, that Benjamin Holt perfected the track-type tractor in 1904.
The CAT D11 is equipped with a similar but more sophisticated track technology. It has an elevated sprocket undercarriage, also known as HXDL. This heavy-duty undercarriage is specifically designed to reduce scalloping in high abrasion conditions. The main part of the tracked undercarriage is its metallic chains, which consist of crowned rail links. These rail links are interlocked with each other by bush locks. The front and back idlers and the bottom rollers serve just to rotate it smoothly, while the upper sprocket takes power from the main drive to push the whole chain. The credit for the crawling undercarriage goes to Benjamin Holt, but he's not what made these tractors into dozers. The dirt-pushing blade is registered as a patent in the names of a farmer and a draftsman. In 1923, James Cummings and J. Earl McLeod collaborated to design a blade that could be attached to the front end of Holt's tractors. After 2 years, their invention was accepted as a patent. The same year, Holt Manufacturing Company and CL Best Tractor Company merged into one entity, Caterpillar Tractor Company. Tractors of this decade can be seen in black and white pictures, boasting a large, thick metal plate in the front. 3 different types of blades have become common in use. This includes the S-blade, the U-blade, and the SU blade. The S-blade is the simplest blade. It is usually short and has no lateral curves or side wings. It is best suited for fine grading, ditching, and stripping jobs. The U-blade is also known as the universal blade. It features large side wings to carry more material. The U-blade is also the largest blade type in both height and width, and is best used with soft to medium density soil. Some of the best tasks for U-blades include ditching, hauling, pushing, and crowning. The SU blade combines the features of both the S blade and the U blade to provide more substantial penetration and better overall versatility. It's less curved, and its side wings are smaller than a normal U blade. It's used to push soft to medium density sand and soil over long distances. Crowning, moving heavy material, stumping, and ditching are some of the best uses for an SU blade. Many suppliers were offering special blades designed for Caterpillar track tractors. But in early 1945, the company decided to develop its own line of dozer blades. Decades of dozer research and development have made Caterpillar the leader in blade technology. Caterpillar now manufactures a wide range of blades for its machines that perfectly meet quality standards. However, aiming for excellence is one thing, but striving to push your own boundaries is quite another. The well-engineered design of the D11 was an example of such a push. The latest generation of this dozer has a 29.3-degree interior angle between the rear bottom of the blade and the ground. This clearance angle further improves the blade's ability to grade and load. The D11 can be outfitted with a large variety of different blades, such as a 35.6 cubic yard SU blade or a 57 cubic yard U blade. Competition produces the best products, especially when rivals are equally capable. The closest competitor of the CAT D11 is the Komatsu D475, which is the largest dozer in the world. It is 38 feet 9 inches long, 20 feet 4 inches wide, and 15 feet 5 inches tall, bigger in every dimension than the D11. But in terms of performance, both dozing titans stand side by side. As a matter of fact, the CAT D11 can hold a bigger blade, albeit by not that much, and consumes less fuel. Because of Caterpillar's long history, the D11 has many advantages over other competitors. Technologically, it's still considered ahead of other dozers. The backbone of any dozer is its robust frame. In the case of the D11, the main frame is made by casting high-strength steel. It supports the whole structure and absorbs high-impact shock loads and twisting forces during service. The main structural skeleton is formed through the welding of steel plates. Caterpillar uses welding robots equipped with vision technology to ensure an accurate measure of the performed welds, while skilled workers perform prep and tack welds. To create their iconic yellow coats, Caterpillar uses electrostatic painting systems that work autonomously. Next, the transmission and the engine are mounted on the frame. After assembling the hydraulic cylinder and blades, the cab is installed. Once all is done, electrical lines and fluid lines are attached to fitted connections. In October of 2018, Caterpillar celebrated the manufacture of their 40,000th CAT large dozer. All heavy-duty dozers come standard with dual tilt technology. It allows the operator to pitch the blade forward or backward, depending on what stage of the cycle they are in. This also increases the operator's workload, as they have to precisely tilt down the blade for cutting, raise it back up when not, and roll forward for it to spread. To make this task less tiring, Caterpillar included the Automated Blade Assist. The Automated Blade Assist is also available for the D11. It lets the operator preset the tilting level of the blade. With just the push of a button, they can angle the blade for cutting, moving, or spreading from anywhere. In this way, they don't have to use their arms repeatedly for each pass. Caterpillar also offers an optional 3D grade control system for the D11, which makes the operator's job almost automatic, as well as elevates the grading operation to the next level. The grade control system is based on twin GNSS antennas and an array of inertial measurement unit or IMI sensors. This cutting-edge technology automatically measures the conditions and precisely adjusts the blade motions, including lift and tilt. For dealing with tons of soil materials, a dozer needs a powerful engine that can provide high torque throughout all daily duty cycles. This problem can be solved by simply using any high horsepower engine, such as the CAT D11. It's the most power-dense, high-speed diesel engine ever, providing more than 840 horsepower and a peak torque of 4,548 pound-feet. But an increase in horsepower means more fuel consumption, which is one of the most important aspects to consider for working costs. It also does not solve the lagging that occurs when a dozer utilizes more or less energy than needed for the load. To cope with such issues, Caterpillar smartly devised a whole new electric powertrain for all of their flagship dozers. The XE version of the D11 is the most fuel-efficient dozer on the market. Its powerful diesel engine is connected to a generator, which converts the mechanical output into electrical energy. A control unit transmits the required energy to all derived terrain motors. Subsequently, the engine does not have to change revs nearly as much, with the excessive power, if generated, stored for later use. It also solves the lagging problem, since the electric motors are many times more responsive than a mechanical gearbox-based drivetrain. This also ensures exceptional maneuverability with zero gear shift, less downtime, and longer rebuild lifespan. Ultimately, what this means is that Caterpillar has tried to create a powertrain that optimizes power to the ground with durability and ease of service to deliver a low cost per ton in dozing applications. As the saying goes, with great power comes great responsibility. In this case, a responsibility to keep the operator safe, which is why it comes packed with plenty of safety features. In the event of emergencies, its engine shuts off automatically, and the factory-installed fire suppression system activates instantly to extinguish fires within seconds. Guardrails, sensors, and cameras are all around the machine. Its power ladder is stored in sections when not in use. Thanks to large windows, mirrors, and display screens, the operator always has a 360-degree view of his or her surroundings. The D11 senses whether the operator is on the seat or not, and it automatically locks the powertrain to prevent unintentional movement when the driver leaves the seat. The CAT MineStar is a new object detection system. It adds radar capabilities to boost awareness of what's happening around the machine. This technology can automatically identify objects and alert the operator for potential hazards, regardless of whether the danger is in front, behind, or within the turning radius on each side of the machine. It also highlights specific views to show operators where potential hazards may be located. Improving something that is already ahead of its time is certainly a difficult task. Caterpillar needed to collect a team with a strong passion, foresight, and commitment. Enhancing productivity is always important, but there is a requirement, more than ever, to ensure safety for the operators and to maximize efficiency. One such example is the recent development of a remote operator station that is able to control the machine wirelessly. Wolf Group is the first company in Australia to use this technology. They have thus far deployed 6 D11 dozers to work remotely at a mining site, producing consistent quality results and removing the chance of operators being injured in an accident. At the same time, this is an alien experience for operators, something entirely new. Now, instead of sitting inside the cab, they operate the machine remotely. They do not experience vibrations and noise in the same way anymore. But it seems, according to what we've seen so far, that they do not get tired as quickly, reducing operator fatigue. Along with remote control, D11 dozers are now available with semi-autonomous operation. It enables a single operator to operate up to 4 machines in push-to-an-edge applications, maximizing dozing efficiency while site operational expenses are reduced. This system responds to mapping environmental changes in real time and is intended to handle operator interventions fast and seamlessly. In the future, Caterpillar wants to make this beast of machine fully autonomous. The D11 is most typically used in large-scale forestry, mining, and quarrying operations. Because of this, it is always going to be a challenge to get it from the point of manufacture to its final destination, which is usually going to be in a remote location. The D11 is not a Mini Cooper, and the process of getting it anywhere is complex. At the very least, it is partially dismantled before being sent to most locations. In the United States, some are carried by flat car trains, without the blade, push arms, or ripper frame. Others are disassembled into many parts, making it easier to put into a number of different trailers for transport. From the mining sites of Australia to construction projects in Europe to the farmlands of the USA where its whole story began, the D11 can be found anywhere in the world dozing Earth with elegance. After all, it's the uncrowned king of its class.
Do you know that only 53 Komatsu D575A superdozers were ever built in the world, while Caterpillar has produced more than 6,000 D11S since 1986? The Komatsu D575A, once the largest production bulldozer ever made with a massive 1,150 horsepower engine and the ability to push up to 125 cubic yards in a single pass, was a rare engineering marvel, but eventually discontinued in 2012 due to high costs and limited demand. In contrast, Caterpillar's D11 became the true global workhorse, with thousands still operating in mines across the world today, from coal pits in Australia to iron ore fields in the US. The D11 continues to evolve, with the latest models offering about 6% lower cost per bank cubic meter compared to earlier versions, a huge financial edge in large-scale mining operations. While a brand new D11 can cost between $2 to $3 million and used models can range from $400,000 to $3 million, companies still invest heavily because the machine can run for decades, with some dozers logging more than 100,000 hours in service. Operating costs typically hover around $500 to $1,000 per hour, but the productivity offsets make it worth every cent. The Komatsu D575A may remain a legendary giant with a few preserved in museums and yards, but in terms of profit, reliability, and sheer numbers, Caterpillar's D11 clearly dominates the bulldozer world. That's the story we're about to uncover. Today, we're staging one of the most requested and hotly debated heavyweight fights in the world of heavy machinery. The Komatsu D575, the largest production bulldozer ever built, versus the Caterpillar D11, the dozer that many operators, mechanics, and mine managers alike call the best in the world. This isn't just about who's bigger, it's about who works better in the real world, who keeps moving Earth shift after shift, who companies continue to buy and rebuild, and which machine has truly earned the trust of the toughest industries on Earth. The Komatsu D575A-3 superdozer is, without exaggeration, a mountain on tracks. In its largest configuration, this behemoth stretches nearly 39 feet long. Across its superdozer blade, it spans almost 24 feet wide. And when you stand next to it, you're staring up nearly 16 feet to the top of the cab. Fully outfitted, the D575 tips the scales at a staggering 336,000 pounds. That's more than 150 metric tons of machine, dwarfing the weight of 2 Boeing 737 passenger jets. And then, there's the blade. The blade is the defining feature of any dozer, and Komatsu built the biggest one ever. The D575's blade can push a jaw-dropping 125 cubic yards of earth in a single pass. That's about the same volume as 150 pickup trucks worth of material being shoved forward in one single motion. Watching the superdozer at work, you don't get the impression of a machine cutting ground. It looks like a steel cliff face advancing, shoving aside hillsides as if they were piles of sand. By comparison, the Caterpillar D11 is smaller. Its operating weight sits in the range of 105 to 115 metric tons, depending on the configuration. Its blade capacities range from 35 cubic yards with a semi-universal blade up to 57 cubic yards with a carry-dozer blade. When you build machines at this scale, size alone isn't enough. The way a dozer puts its weight to the ground, the way it grips, climbs, and powers through terrain can make the difference between a machine that works and a machine that spends more time in the repair bay. The Komatsu D575 relies on a conventional low sprocket undercarriage. It's a tried and true design, robust and simple, and on most bulldozers it gets the job done without complaint. But when you take a design meant for 60 or 70 tons and scale it up past 150, the stress becomes punishing. Every pin, every roller, every shoe takes the full brunt of the D575's enormous weight. In abrasive rock or compacted soil, these forces chew through undercarriage components at a brutal pace. Keeping a D575 running smoothly requires meticulous maintenance schedules and parts that aren't exactly easy to source today. Caterpillar approached the problem differently. Back in the 1970s, when they were developing what would eventually become the D10 and then the D11, their engineers introduced the elevated sprocket high drive system. It was a radical idea. Lift the drive sprocket up above the track frame, keep it away from ground shock, and allow the track to float with a suspended undercarriage. On paper, it seemed like a bold gamble. In practice, it changed everything. The high drive isolates shock loads before they reach the final drives, reduces scalloping, the uneven wear tracks get from pounding into the same hard surfaces again and again, and spreads more track on the ground at once. The result? Better grip, smoother ride, and significantly longer component life. Then there's the blade, the heart of any dozer. The Komatsu D575 still wears the crown for biggest blade ever fitted to a production bulldozer. Its 125 cubic yards superdozer blade is a staggering sight. Standing in front of it, the steel wall looms higher than a two-story house. Watching it cut into a bank is like seeing a glacier shove through a valley. It's not just a blade, it's a moving horizon line. The Caterpillar D11, by comparison, looks more modest. Its blades range from 35 cubic yards on the semi-universal to 57 cubic yards on the carry-dozer version. At first glance, that's barely half the size of the Komatsu. But blade size alone doesn't decide who moves more dirt. Caterpillar's blades are engineered for efficiency. The semi-universal blade digs deep and penetrates tough soils. The carry-dozer blade scoops material, holds it, and carries it further without spilling. The geometry of these blades isn't just about capacity. It's about balance, traction, and consistency. And then there's technology. The D11 integrates automated blade assist, letting operators preset blade angles for cutting, carrying, or dumping. With the push of a button, the blade adjusts itself. Auto Carry automatically keeps blade loads consistent through the push, reducing track slip and maximizing efficiency. And with CAT grade with 3D, the dozer ties into satellites and sensors, guiding every pass with near-survey precision. The results are not just theoretical. In a Nevada gold mine, operators reported a dramatic boost in shift-wide productivity after adding auto carry. Even though the D11's blade was smaller, The system kept each pass consistent, which meant more total tons moved by the end of the shift. The lesson was simple but powerful. A blade that's smart can outwork a blade that's just big. For operators, this translates into less fatigue, more predictable cycles, and higher production numbers. Instead of constantly fighting to find the perfect angle or second-guessing load balance, the machine assists them. That difference is one of the reasons why so many mines worldwide keep choosing the D11. Of course, no showdown between giants would be complete without talking about what's under the hood. Power is the headline spec that grabs attention, the number that fans debate and mining companies analyze before signing a contract. The Komatsu D575 carries one of the most powerful engines ever dropped into a bulldozer. A mammoth 12-cylinder, 1,150 horsepower diesel engine drives this machine. When the Super Dozer was first introduced, those numbers were staggering. This wasn't just a dozer. It was a groundbreaking experiment in how far brute strength could be pushed. For decades, Komatsu's V12 allowed the D575 to slice through Japan's massive open-pit coal mines, benching entire walls of earth and rock with brute force. Standing next to a running D575, you feel the ground vibrate. The sound is a guttural roar. A reminder that this was a dozer built to dominate through sheer horsepower. It was, and remains, a legend of mechanical muscle. But raw horsepower has limits. The Caterpillar D11 doesn't match the D575's peak numbers on paper. Its CAT C32 engine produces between 850 and 950 horsepower, depending on the model. To the untrained eye, that looks like a loss, a smaller number in a contest where bigger seems better. Yet, Caterpillar added something Komatsu never did: a new way of delivering power. Enter the D11XE, Caterpillar's diesel-electric dozer. Instead of relying solely on mechanical transmissions, the D11XE uses the C32 engine to drive a generator. That generator powers electric drive motors, which then deliver torque directly to the tracks. The advantages are massive. Electric motors deliver instant torque. They don't need gear shifting. They respond instantly to operator input, and they're far more efficient at converting fuel into usable work. Field tests and customer reports show that the D11XE uses up to 25% less fuel per unit of material moved compared to traditional mechanical drive versions. For mines in Western Australia or the Powder River Basin, operations that burn tens of thousands of gallons of diesel every single day, that efficiency translates to millions of dollars saved annually. Less fuel burned also means fewer emissions, something more and more companies are being asked to address. So while the D575 wins the horsepower battle on paper, the D11 wins the war of economics. Because in mining, where margins are thin and downtime is expensive, saving millions in fuel while maintaining consistent torque delivery isn't just impressive, it's decisive. But power is only part of the story. Safety is where the biggest changes in dozer design have happened since the D575's heyday. When the Komatsu D575 was built, safety features were limited. Machines were designed to be strong, and operator safety often meant little more than heavy steel around the cab. Remote control use was experimented with in special conditions, but it never became widespread. The D575 was built in an era when autonomy was still a dream, and the priority was brute capacity. The Caterpillar D11, especially in its modern variants, reflects a very different era. From the factory, it comes equipped with automatic fire suppression systems, guardrails, powered access ladders, and reinforced rollover protection structures. The cabs are designed not only for strength but for visibility. with wide windows, extended mirrors, and high-definition display screens feeding 360-degree camera systems. Operators are kept safer and more aware of their surroundings. But the real revolution is autonomy. With CAT command for dozing, the D11 can be run remotely from a safe control station, or even semi-autonomously. In repetitive push-to-edge tasks, one operator can supervise multiple machines, sending commands to several D11s working simultaneously. And this isn't theoretical, it's happening right now. In Western Australia, some of the world's largest iron ore mines run fleets of semi-autonomous D11s supervised from control centers miles away. Operators sit in air-conditioned rooms, monitoring multiple screens, while their dozers work in the dust and heat without a human in the cab. The benefits are massive. Reduced operator fatigue, fewer accidents, and higher consistency shift after shift. For mining companies, autonomy doesn't just protect people, it boosts productivity. A machine that never gets tired, never loses focus, and always follows its programmed path delivers predictable, repeatable results. In the long run, that consistency is worth as much as raw horsepower. The Komatsu D575, for all its legend, never made that leap. Its era passed before remote control and autonomy became the new benchmark. The Caterpillar D11, still in production and constantly updated, embraced it. And that decision changed the game. When you put power and safety together, the contrast becomes clear. The Komatsu D575 will always be remembered as a monster of mechanical strength, a dozer that pushed the limits of what was possible with sheer size and horsepower. But the D11 has evolved into a machine that combines strength with intelligence, protection, and adaptability. There's one more reality we need to face: getting these giants to the job site. The Komatsu D575's enormous size makes it a nightmare to move. To redeploy, it has to be disassembled into multiple truckloads, each hauled separately, then reassembled with cranes and a team of specialists. The process takes weeks and costs a fortune. In practice, this means the D575 is a stay-at-home champion, a dozer meant to live and die in one mine without ever leaving. The Caterpillar D11 was designed with flexibility in mind. Remove the blade and ripper, and the main body can be hauled on a low loader or even by rail. In regions like Australia's Pilbara, operators move D11s partially intact under oversized permits, saving both time and money. For mining companies that shift fleets between sites, that's a massive advantage. Then comes the final piece of the puzzle: support. Komatsu only built around 53 D575s. That means parts are rare, and technicians trained to service them are even rarer. When a component fails, downtime stretches, not because the machine isn't powerful, but because the network to sustain it simply doesn't exist. The Caterpillar D11, with over 6,000 units in service worldwide, is the opposite. Caterpillar's dealer network is unmatched. Parts are stocked, rebuilds are routine, and upgrades, from basic kits to full autonomy, are readily available. Mines know they're not just buying a bulldozer, they're buying into a platform that will be supported for decades. That reliability, more than anything else, is why the D11 dominates fleets in Canada's oil sands, South Africa's diamond pits, Brazil's iron ore mines, and America's coal basins. So, who really wins this showdown? The D575 will always be remembered as the largest. The D11, for the world that actually moves mountains, will always be the best. So what do you think? Would you put the Komatsu D575, the mountain-sized legend, to work in your pit? Or would you trust the Caterpillar D11, the proven king of bulldozers? Let us know in the comments below. And if you enjoyed this battle of giants, don't forget to like, share, and subscribe to Lord Gizmo for more incredible machines and the stories behind them. the Gessner CAT D11, a beast born for extreme earth moving. Designed by Gessner Industries, it transforms Caterpillar's legendary D9T bulldozer into a land-clearing powerhouse. Massive rippers and custom blades tear through rock and soil like butter. Reinforced frames handle punishing workloads in the world's toughest terrains. Operators trust its brute strength to shape roads, mines and farmland with surgical precision. The Gessner CAT D9T isn't just a machine, it's unstoppable force, engineered for total ground domination. This is a Dixie holding attachment, a heavy-duty tool built to push your machine further. Designed by Dixie Industries, it bolts onto excavators and loaders to lift, grip, or move massive loads with ease. Precision hydraulics give operators total control even in tight spots. Built from high-strength steel, it handles brutal workdays without breaking a sweat. From construction to forestry, the Dixie holding attachment turns raw power into unmatched versatility. Meet the Dixie Holdings D7R2, a precision-engineered powerhouse for the toughest terrain. Crafted by Dixie Holdings, it transforms the legendary D7R2 bulldozer into a multi-role workhorse. High-torque drive systems and reinforced undercarriage push through rock and mud. Advanced hydraulics control custom blades with razor-sharp accuracy. Built from military-grade steel, it endures brutal workloads day after day. This isn't just strength, it's precision force, ready for any mission. This is the gravel sweeper, a rugged attachment built to tame rough surfaces fast. Designed for loaders and skid steers, it uses heavy-duty rotating brushes to sweep gravel, dust and debris in a single pass. Adjustable bristles dig deep but protect the base layer underneath. Hydraulic drives keep the brushes spinning strong, even on uneven ground. From construction sites to farmyards, the gravel sweeper turns messy lots into clean, safe workspaces in minutes. Pure power, clean results. This is the Root Rake by Winsco, a land-clearing giant with unstoppable grip. Built for dozers and loaders, it rips roots, stumps and debris straight from the ground. Heavy-duty steel tines slice deep into soil, pulling tangled roots free with brute force. Wide spacing lets dirt fall away, leaving only what needs to go. It clears forests, preps sites and reclaims overgrown land in record time. The Winsco Root Rake, total control for total land domination. This is the Stick Rake by Curry Engineering, a brutal force built for clean land fast. Heavy-duty steel tines rip through the tangled roots, branches, and stubborn debris in seconds. Reinforced frames handle massive stress without bending. Hydraulic arms tilt and lift with pinpoint control, clearing wide paths in fewer passes. Dirt sifts through while unwanted mess stays trapped. Forestry, farms or construction sites, it preps ground for new projects with ruthless precision. The Curry Engineering Stick Rake, total land control in the palm of your machine. This is the Himmak Skid Steer Push Rake, a land-clearing weapon made for serious ground control. Designed by HIMAC attachments, it mounts to your skid steer in seconds. Heavy-duty tines rip through roots, brush, and debris with ease. The angled frame pushes material forward, leaving clean, level ground behind. Strong welds and reinforced steel take punishing loads without flinching. One pass clears what others can't touch. The HIMAC push rake, pure muscle for transforming wild land into ready ground. This is the Savannah 1250 rotary brush stick rake, a heavy-duty clearing machine built by Savannah Global. Its massive rotating drum spins tough steel tines that shred thick brush, roots, and small stumps in one relentless pass. High-torque hydraulics keep the drum turning through stubborn tangles and rough terrain. An ultra-strong frame absorbs brutal impacts without slowing down. Operators clear wide paths fast, leaving clean, ready-to-work land behind. The Savannah 1250, pure rotary power that conquers the wild and reclaims the ground. This is the Savannah 1710 stump puller, a brute force solution built by Savannah Global. Heavy-duty jaws clamp tight around stubborn stumps. Hydraulic cylinders unleash massive pulling power to rip them straight from the ground. Reinforced steel arms handle brutal forces without bending. Deep grip tines dig in and tear out entire root systems in seconds. No burning, no grinding, just raw, clean removal. The Savannah 1710 stump puller. Unstoppable strength that clears the way for what's next. This is the Savannah Magnum 240 bedding plow, a soil-shaping powerhouse built by Savannah Global. Heavy-duty steel shanks cut deep, carving perfect rows through tough ground. Hydraulic controls adjust depth and spacing on the move. A reinforced frame keeps it steady under massive loads. Wide blades turn rough soil into smooth rongprants. Uniform beds in a single pass. Farmers trust it to prep fields faster and plant sooner. The Savannah Magnum 240, precision plowing that turns raw land into ready harvests. This is the Multi-Farming 24 hydraulic lift pin wheel rake, a precision tool built by Multi-Farming Systems. 24 tough pinwheels spin fast, sweeping hay and crop rows clean in one smooth pass. Hydraulic lifts adjust height and pressure instantly for perfect ground contact. A sturdy frame floats over rough terrain without missing a strip. Wide coverage means fewer passes and faster baling. Clean windrows and zero wasted crop. The Multi-Farming 24, smart raking that turns fields into harvest-ready rows with flawless efficiency. This is the HIMAC Extreme Duty Rock Picker, a brute force rock removal system built by HIMAC Attachments in Australia. It mounts to skid steers, loaders, and telehandlers with ease. Heavy-duty steel tines scoop and sift rocks straight from the soil. A high-torque hydraulic motor powers the rotating reel, lifting stones up to half a meter wide. Shock-absorbing springs protect your machine and keep the job smooth. Faster, cleaner, safer than picking by hand. The HIMAC Rock Picker, unstoppable grit for rock-free, ready-to-work ground. This is the Rober stick rake, a precision land-clearing powerhouse built by Rober Attachments. Heavy-duty steel tines dig deep into roots, brush, and debris. Reinforced arms withstand brutal force without bending. High-flow hydraulics deliver exact control over depth and angle. Wide reach covers more ground in fewer passes. Soil filters through. Unwanted material gets trapped. Clean ground in motion. From forestry to construction sites, it preps terrain with surgical precision. The Rober stick rake, engineered force that transforms wild land into clear, ready space. This is the Homan Equipment D9T, a Caterpillar bulldozer upgraded for brutal land clearing. Homan fits the legendary D9T with a heavy-duty stick rake that rips deep roots and dense debris in a single push. Massive steel tines tear through forests and fields without slowing down. High-flow hydraulics keep every pass smooth and precise. Reinforced arms absorb crushing force day after day. Together, blade and rake turn wild ground into clean, workable land. The Homan D9T, raw cat power, refined for unstoppable clearing.